One concept that we want to ensure that we feel comfortable with is the idea and the difference between linear growth versus exponential growth. Linear growth occurs at a constant rate of change. We generally represent this as a linear equation in the form of y equals mx plus b. As you see on the image on the left, there is a line and I have the letter M on that line. Slope is your rate of change. It is how steep or maybe how high a graph is going. I use the word high, but you can actually have a positive or negative slope. So if you think about the slope of a mountain, if you're thinking about going skiing and you say, oh, well, what's the slope of that mountain? You're basically asking about its steepness. How steep, how quickly does it drop? What is the level of that fall? And so it can be a positive or a negative slope. When I look at the b value, I am concentrated on the y-intercept value. So I want to know, where does this line cross my y-axis value at? Now, we love the concept of linear growth. We love things that occur linearly, where they're constant. Again, that constant rate of change. So things are going to be changing with a pattern. So, adding 2 every time I increase by 1. There's this constant idea. But unfortunately, in life, if we create models for real-time data, it's very rare that we have linear models. Now, we tend to make a line of best fit because we want to try to create lines for real-time data, but it's very rare that we ever get perfect data. If I were to look at the amount of sales a business makes from month to month, those sales are not going to be the same. I'm not going to make 10 sales every single month. There's going to be months that are higher, maybe around holidays. My sales are going to be higher, and then there's going to be points where my sales are lower. Think about if I'm selling pools. It's more likely that in warmer weather months, I'm going to sell more pools, and in the winter months, I'm probably not going to sell as many pools, right? So real-time data generally is not linear. So that's why we want to understand the concept of an exponential growth. Exponential growth occurs very rapidly. We can grow or we can decay. So if I'm increasing in value, I would be growing. I would be headed up, as you see my graph on the left shows. But I could also represent an exponential decay, and that would be data that quickly falls, and so it'd be going down. These take on the form of the equation y equals a to the x power. So in a linear function, notice how your x is a number value. It's not an exponent value. It's sitting right beside your slope. But in an exponential growth, that x value is actually in the exponent place. So very different and definitely very interesting. So if we actually compare two similar kind of concepts, so you notice that my base values are 2 here, but my blue line is representing a linear equation, so I actually have y equals 2x, so that means that my slope value is equal to 2, whereas over here I have, in the red, I have an exponential model, so my a value, which is the base, is equal to 2. You can see how the models of their graphs visually look very, very different. And then furthermore, if I come over here and I concentrate on the y values, I can see how these rapidly change as well. I'm kind of having this constant, adding 2 when I have the linear model. So I notice that pattern of just adding 2 each time, and it continues on. Whereas on my exponential model, there isn't this just adding 2. I'm raising values to an exponent, and I'm growing super, super quickly. So on the linear model, by the time I got to 10, I only had a y of 20. But on the exponential model, by the time I plugged in 10, I had a y value of 1024. So exponential data models can definitely increase or decrease much quicker than a linear function would. And we'll have a second video where we'll go a little more in depth about this concept. But as always, if you have any questions, again, this was just kind of an introductory video to get you thinking about linear and exponential models. But if you have any questions, please don't hesitate to reach out.